Okay, hopefully you had some luck solving those third right-hand rule problems. Again, if you're struggling with them, I can help you out on Friday. So just see me then and we can go through them together. Now what I'd like to do is start to talk about why this is useful. Why do we care about this? One of the big things, the big takeaways from this unit is that current carrying wires generate a magnetic field, and when that magnetic field is placed inside of a magnetic field of another magnet or another wire, a force is generated. And really what that boils down to is we can then create motors or things that spin that can then do useful work. I'm going to show you a video clip that's about 3 minutes long or so of a physics teacher going through and kind of explaining how a motor works. If you want to take notes on this, you absolutely can. One of the activities today is you guys are going to build a motor, and as you build that motor, at the very end, I'm going to have you fill out a sheet of paper basically drawing a diagram of the motor, identifying the force, the current, and the magnetic field on your motor, and then in a few sentences explaining how it works, and you're going to turn that in. So if you want to take any notes as this guy explains it, just so you're kind of getting an idea on how a motor works ahead of time before the lab even starts, not a bad idea. Just a heads up, this guy, he does the third right-hand rule differently than how we do it in this class, so just be aware of that. He's going to make kind of like the gun-looking symbol that looks kind of like this. If you want to use that, I don't really care, but just so you're aware, he does do it a little bit differently. So let's take a look-see at this video on how a motor works, and then we'll get back together to talk about what we're doing today.
What I'm about to explain to you had a transformational effect on society in a very fundamental way. We changed our experience of life based on this profound application, well, a profound application of this particular effect. So I'm setting up a magnetic field right here, and my plan is to get a loop of wire with a current in it. There it is. So I'm making a current go up this wire, go around clockwise like that. And the cool thing is that this wire, as a result of the current and the magnetic field, well, there will be forces on sections of the wire. So let's investigate each of those sections in turn. In particular, first, let's figure out the force on this section right here. Well, current's going that direction, that way, and the magnetic field's going the opposite direction, so if I try to find the force, it'll be like, break my hand. No, so there's no force here. The force on this wire is 0, and the force on that wire is 0. Similarly, up top, the current is in the direction of the magnetic field, so I guess that means we've got electrons going that direction, but there's no force because there's no angle between them, because the angle is 0, so you're taking the sine of 0, and that's just nothing at all. But here, we've got current going up the wire. And we also have the magnetic field that direction, so we can look at it in two ways. One, we'll look at it in terms of the electrons. So electrons are going down, and this is going to be hard with your computer screen, but they're going this way, and the magnetic field is that direction, so I'm going to put my like that and then go like this, and I see that my thumb is pointing into your screen and into my page right there. So there's a force that's inward over here, and I draw it like that. That's the direction of the magnetic force on this current carrying wire. And there are also electrons, let's continue the electrons, they're going this direction, and magnetic field's that way. If I do that, then you see that the force is outward in this case. So there we've got an inward force, and here we've got an outward force, and there's no force on the top or on the bottom, and there's some force on these guys, but it cancels out, and they're kind of right in the middle and right next to each other, and we try to make sure that there's only this force here, and that force there. That force, wow, is there a net force? Is there a, ooh, gosh, is it doing anything at all then? If I push that down and I pull that up at the same time, we're going to get a net torque. Okay, that's pretty exciting. Now, let's look at it again from the perspective of the current though. Now, we pretend that there are positive charges moving this way. So I'm going to say positive charges that way, magnetic field, I'm using my right hand this time, magnetic field that direction, so I go like that, and I find that the force is still into the page, and if the magnetic field is to the right and the current is going down, then I go like this, and I find that the force is out of the page. So I don't care whether you say electrons are going this direction or protons are going that direction, you're going to get the same direction for the force. So whether you're honest about it or you just gloss over the whole effect that Benjamin Franklin got the current wrong, it doesn't matter. You're ready to rock. There will be a net torque on this sucker, and it will rotate about this axis. So I'm going to put an axis right here that it can rotate about, and we want to figure out how much that torque is. So I have to define some quantity.
Okay, he goes into more stuff than what I care to discuss right now, so don't worry about that. But the big takeaway, if I just rewind this video here a little bit, is this what appears to be a coat hanger is going to start to rotate in a circle because the left side is being pushed into the paper and the right side is being pushed out of the paper, and it's going to start to cause it to spin, kind of like what a motor does. The next thing I'm going to do is I'm going to show you guys a short video on how to make a motor. This isn't exactly the instructions on how we're going to do it, but it's pretty close. And since I'm not there to help you through this whole activity, I thought this is the next best thing. So I'll show you a short video on how to make a motor, and then I'll go through our lab write-up and how we're actually going to do it, and then let you guys try this experiment out. It can be pretty cool. So let's take a look-see at this. Okay, so let's take a look-see at our motor lab, and I'll try to point out where we have some similarities and some differences going on. So here are the directions for making this motor. Step one is basically you're going to get about an arm's length worth of wire. So I'm just going to have someone walk around and cut you an arm's length of wire, and you're going to take it and wrap it around a marker. A marker is just kind of easy to wrap around. You could use a pen, a pencil, or something, but basically a marker is probably what we're going to use. And you wrap it around it 10 or 15 times, leaving two ends hanging off, kind of like that guy had on the video. So you don't want to wrap it all around the marker. You're going to have like two arms, if you will, coming off of the coil of wire. I encourage you to leave more than a few inches of wire hanging off the ends, because in the end, if it's too long, it's very easy to cut the wire, whereas it's very difficult to actually add wire on. Actually, frankly, if you cut it too short, you're almost better off just getting a new one and starting all over again. After you take the coil of wire off of the marker or the tube, wrap the ends around the coil at opposite points, kind of like in this picture here or in this picture here. It's hard to kind of see in these, but basically you just take the wire and you kind of loop it over itself a couple times to kind of like tie the coil of wire off together. You really want to try to make it as symmetrical as possible. So notice in this picture with the blue background, these arms coming off of the coil of wire are in the same, like at the same level as each other. You can use some tape if you want. Though every one I've ever made does not actually use tape. So I just wrapping the wire around itself like 2 or 3 times seems to be adequate to hold it together. After you make the coil, you should have some paper clips, and you just basically take the paper clips, and I take one, I just fold it up and make it long, and then I take one and just kind of fold that out so that you get a little like hook, if you will, to basically stick the arms of your coil of wire into. After that, you'll take some apparatus. It might be this white cup. We might use beakers. I'm not real certain what the plan is right now, but inside of this white cup there is a weak black ceramic magnet that I put on the bottom of the cup, and then I put a strong, they're called neodymium magnets, on the top of it, and basically the two magnets are attracted to each other and they kind of stick to the top of the cup. If we're using a beaker, the same procedure would probably work, or you could even tape the magnet to the top of the beaker or the cup, and that would work as well. And also to this cup or the beaker, you're going to tape your paper clips going up, such as what's in this picture right here. I'll see if I can make this bigger real quick. Tape the paper clips going up, and then notice I have the 2 little spots where you can put the arms from the coil of wire into those spots of the paper clip. Before you put your coil of wire in those paper clip spots, though, it's really important that you sand or scrape the bottom of the wires. You're going to take that red enamel off of it so that you see shiny copper underneath. If you see red enamel, that means you're not going to be able to conduct electricity through it. It's basically an insulator, and so that has to come off. But you're only doing it on the bottom side of the wire. So if my finger is the wire, you're going to sand the bottom of both sides of your wire, but not the top. So one side will have red enamel on it, and the other side will not have it on it. So this picture isn't the best to show it with, but you can see me here with I'm using a razor blade to basically scrape the red enamel off of this side of the red wire. I'm going to do the same thing over on this side as well, but just the bottom. If I were to flip that coil of wire over, the other side would have the red enamel still intact. Okay. After you've done that, you can then use the perch that you made out of your paper clips to place the coil in that perch. This is by far the trickiest step. You need to be able to, basically I take my finger and I kind of just flick the coil of wire to cause it to spin or rotate in the perch. And it's not going to keep going because we haven't hooked it up to any electricity yet, but it needs to be able to easily spin. If it can't easily spin, it's not going to work well. So this is me trying to do that with a coil of wire, and you can see right here, this one isn't spinning that well. I flick it and it doesn't keep going very easily, and so that's not so good. You want it to be able to easily rotate around in a circle, and this is not doing that. After a little bit of adjusting, you can see in this one, I'm able to flick the coil and it spins pretty easily. So if I bring that back, these are real short clips, but if I flick it, it spins pretty easily, and that's good. That's what you want to try to shoot for. So before you even hook up any electricity, you really want it to be able to spin very easily. Once you've done that, you then are to the easy step. You connect the power supply with alligator clips to each of the paper clips to then run an electrical current through the wire. And doing that, and you kind of keep flicking the coil, you're then able to get that motor to start spinning. I think I have an example of one that actually is working right here. And I gave it a flick, and here it goes. It just I actually had this running for about 40 minutes straight, and I finally turned it off after I went home for the day. So it'll just keep on going until you take the electrical current away from it. So this is what you're trying to shoot for, is something like this. On the lab, there are some troubleshooting tips just in case you are struggling, and help one another out. This lab can be very frustrating because some people never get it and others get it on the first try, so it just kind of depends on your situation. When you're done, once you've built the motor, you want to draw a picture of your motor, identifying the current, magnetic field, force, acting on the loop of wire, and then write 1 or 2 sentences describing how the simple motor works. Turn that into the hanging file, and that then we'll have an AOR at the end of the block. Have a great rest of the day, guys, and we'll talk to you next time.